Okay, so now let's continue to look at one integral problem in this format, which is integral sine to the power of m times cosine to the power of n dx. Okay. So in the previous video, we talked about if at least one power, either m or n, is odd number, then we can split that odd number into an even number plus 1, and then make some identity transformation, and then apply the use substitution. Okay, so in this example, is when m and n, they are both even numbers. Okay, and then the approach is different. So the formulas we're going to apply, which is given here, and you can see that it's, if you have sine square theta, it's going to equals 1 minus cosine of 2 theta over 2. Okay, and correspondingly cosine square theta equals 1 plus cosine 2 theta over 2. Okay, so those are the two formulas we're going to use to handle that. Okay, so let's start with an example with m and n given. So if we have sine, let's see, square x times cosine to the power fourth x dx here. Okay. Okay, and then like we said, if both m and n, they are even, so we're gonna use those two trig identities to make some substitution. So first we can see that sine squared can be 1 minus cosine of 2x, right, over 2. And cosine squared, which is here, and then I can rewrite into 1 plus cosine of 2x over 2, but I have a square because here is raised to the power 4, and then dx. Okay. Turns out things is not that complicated. Okay, so first of all, let's do some simplification. This is, there is 1 over 2, we can bring it out. Here we have a 1 over 2 squared, that is 1 over 4. So 1 over 2 times 1 over 4 gives us 1 over 8. That's everything from the denominator. So take this 1 over 8 out. We have 1 minus cosine 2x. Okay. Multiply 1 plus cosine 2x, then square dx. Okay. So this is what we got so far. After that, we need to do a little bit algebraic operation. So in other words, 1 minus cosine 2x times, I'm gonna distribute this. It's gonna be 1 plus 2 times cosine of 2x, and then plus cosine square 2x, and then dx. Okay. And then we do another round of distribution to get rid of those two parentheses. Turns out I'm going to have 1 plus 2 times cosine 2x plus cosine square 2x, and minus cosine 2x, okay, and then minus 2 cosine square 2x, and then also minus cosine cube 2x dx here. Okay, so after we do a little bit calculations, so I have 2 cosine 2x minus cosine 2x give us is 1. We have cosine square 2x minus 2 cosine square 2x give us is minus cosine square. Turns out this is what I have. We'll have 1 over 8, so it's 1. That is plus cosine 2x, okay, and then minus cosine square 2x, and then minus cosine cube 2x dx. Okay, so this is what I have here. Well, if we take a clear look to what we have so far, it looks like we can split the integrand into a couple of pieces. First of all, let's look at this. The integral 1 is easy. The integral of cosine 2x is also easy, right? So we put this as a group. Well, second piece, cosine squared 2x. It's also not that challenging because what we can do here is, let me go back. We can use those two, we can use this formula to make a equivalent substitution, and then also we can handle that. Okay, we can handle that. So this is part 2, and then part 3, it's a little bit involved. You have cosine cube 2x. We need have a little bit trick to handle this. So in other words, up to here, I'm gonna split my problem into 3 small ones. So I'm gonna have 1 over 8 bracket integral 1 plus cosine 2x dx, and then minus cosine squared 2x dx, and then minus cosine cube 2x dx, and then I'm gonna handle them one by one. Okay, so let me do this. First, let's focus on inside of this first. Let's see, integral 1 plus cosine 2x dx. Turns out this is going to be x, right, plus sine of 2x, and then over 2. Okay, so I didn't write the actual constant because to the very end I'll add them up. So this is part 1. Part 2, which is here, integral cosine squared 2x dx. Like we said, we can rewrite it into 1 plus cosine of 4x over 2, and then dx. Okay, so this is one of the formulas we provided. And it turns out this is also not that difficult to evaluate. So going to give us is 1 over 2x. And then you're going to have plus sine of 4x. Turns out so for here 1 over 2, the antiderivative is x, 1 over 2x. The derivative of cosine 4x over 2, turns out it's going to be sine 4x, actually it's over 8. Okay, still I ignore the actual constant in minute because to the very end I'm going to add it because this is 3 parts. Okay, so we got 1 and 2 down. Now let's look at it. What about part 3? Okay. Alright, so continue with what we have here. As you can see, the part 3 is cosine cube 2x dx. Okay, so do this. So we're going to have part 3 is integral cosine cube 2x and then dx. And this is going to go back to the example I showed in the previous video. Okay, so you can check in my channel here. Since for here, this power is 3 and it's an odd number, so what we can do here is we can do cosine squared 2x, okay, times cosine 2x and dx. And then I can do 1 minus sine squared 2x, okay, and then times cosine 2x dx. So I can make a u substitution up to here. So take u equals sine of 2x, and then du can be cosine 2x, right? And then also times the 2, because of the chain rule, and then dx. Okay, look at what we have here. We have cosine 2x dx, so du over 2 is cosine 2x dx. So make our u substitution, we're going to have its integral 1 minus u squared, okay, and then times du over 2. That's what we have so far. And then which is 1 minus u squared over 2 du. So this integral is pretty easy to evaluate, which is going to be half u minus u cubed. Actually, it's over 6. Okay. And of course, if you substitute it back, so the result for this is going to be 1 over 2 sine of 2x. Okay. And then minus sine cube 2x over 6. Okay, so this is part 3. So now we can put everything back. So our final answer, the answer is going to be pretty long here. So it's going to be 1 over 8 bracket. So we're going to have x plus sine of 2x over 2. Okay. And we're going to have minus half x minus sine 4x over 8. Okay. And then also have minus half sine 2x. Okay. And then minus minus becomes a plus. Sine cube 2x. Oops, over 6. Okay. And then I need to add an arbitrary constant c. Of course, there's a couple of things you can simplify, right? So it turns out this is going to be, let me write here. So 1 over 8, we have half x, right? This part cancel out. And this minus sine 4x over 8 plus sine cube 2x over 6 plus constant c. Okay. And then we finish this problem. It's a pretty long example here. But let me go through it again so that you get the big picture here. So the problem here is if I have sine to the power m times cosine to the power n dx. That's the format of the problem. And meanwhile, m and n are both even numbers. Okay. Well, most of the time it's positive integers. Okay. And we started with one example, sine squared times cosine to the power 4. And also, we mentioned that you're going to use those two formulas to make the transformation, to make things work. So what we'll do is we rewrite sine squared into 1 minus cosine 2x over 2, assuming the cosine squared is 1 plus cosine 2x over 2 then squared, because this is to the power of 4. And then we do a bunch of simplification. Up to here, this is what we got. And then it turns out this is easy to evaluate. This is also not that bad based on one of the formulas we provided. And then this one we need to use the u substitution. So what we did here is we do the integral for 1, 2, and 3 correspondingly, and then to the very end we put everything back, and then we get our final result. Okay, so that is problem. It's pretty long, but hopefully you can get the main idea is if m and n are both even, so this is how do we start. Okay, so hope you enjoyed this video. Thank you.